Arrangements. When using the fundamental principle of counting, we often multiply a list of numbers in descending order. For example, 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. In mathematics, a shorter way of writing this list is to use the factorial symbol, which is the exclamation mark. So 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1 is written as 5 factorial, pronounced 5 factorial. Formula. The factorial, n factorial, is defined for a positive integer n as n factorial, which is equal to n multiplied by n minus 1, multiplied by n minus 2, multiplied by n minus 3, and so on, all the way up as far as 1. Here's an example. Calculate 10 factorial. This is pronounced 10 factorial. So 10 factorial is 10 multiplied by 9 multiplied by 8 multiplied by 7 multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, which is 3,628,800. We can use the factorial button, n factorial, or x factorial on the calculator. Press 10 followed by the button, either n factorial or x factorial, which should give you an answer of 3,628,800. Factorials can be useful when we are using the fundamental principle of counting, and outcomes have to be arranged in a particular order or position. Find how many ways the letters of the word leaving, so L-E-A-V-I-N-G, can be arranged in each of the following cases. Note, no letter may be used more than once. This is very important. So how many ways can the word leaving be arranged? If there are no restrictions, if the arrangements must begin with a V, if the arrangements must not begin with a V, and if the arrangements must begin and end with a vowel. So let's look at part 1, if there are no restrictions. So if there are no restrictions, we note that there are 7 letters in the word leaving. L-E-A-V-I-N-G, 7 letters. For the first letter of the arrangement, we have a choice of 7 letters. For the second letter of the arrangement, we now have a choice of 6 letters, as 1 letter has already been used. This continues until we come to our last letter, where there is only 1 choice left. So the top row represents the letter, and the bottom row represents the number of choices. So for our first letter in the list, we've got 7 choices. Once we've used one of them, doesn't matter which one, we've only got 6 choices left for the second letter. At that point, we will have used 2 letters, it doesn't matter which 2, so for the third letter, we've only got 5 choices left. At that point, we will have used 3 letters, again, it doesn't matter which 3, so we'll only have 4 choices left for the fourth letter. At that point, we will have used 4 letters already, again, it doesn't matter which 4, so for the fifth letter, we'll only have 3 letters left to choose from, and so on. So we're going to do 7 by 6 by 5 by 4 by 3 by 2 by 1, which is 7 factorial, which gives us 5,040. So how many ways can the letters of the word leaving be arranged if there are no restrictions? There are 5,040 ways we can arrange the word leaving. Part 2. If the arrangements must begin with a V. So how many ways have we of arranging the letters L-E-A-V-I-N-G if the arrangements must begin with a V? So if the arrangements must begin with a V, the first letter must be V. There is only one V, so there is only one choice for the first letter. This means that we now have 6 letters to choose from for our second letter, and so on. So for our first letter, we only have one choice. It has to be a V. So we put a 1 in the box. There is only one choice for the first letter. Once we've used that first letter, which is a V, we've only got 6 letters left. So for our second letter, we've got a choice of 6 letters. So once we've used the V as the first letter, so we've one letter used out of the word leaving, we've used up the V for the first letter. We then have a choice of 6 letters left for the second letter. Then once we've used whatever letter goes for the second letter, we've used up 2 letters, so then we have 5 left out of the 7. So we have 5 letters left for our third letter. And then once we've used those 3 letters, we have 4 letters left for the fourth choice. And then we have 3 left for the fifth, 2 left for the sixth, and 1 left for the seventh. So it's 1 multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, which is 1 multiplied by 6 factorial, which is still just 6 factorial, which is 720. So how many ways can the letters of the word leaving be arranged? If the arrangements must begin with a V, there are 720 ways that we can arrange those letters. So, how many ways can we arrange the word leaving if the arrangements must not begin with a V? So, if the arrangements must not begin with a V, there are a total of 5,040 different ways to arrange the 7 letters of the word leaving, and 720 of these arrangements start with the letter V. So basically that's the answer to part 1, that's the answer to part 2. The rest of the arrangements must not start with the letter V. The number of arrangements that do not start with the letter V is 5,440 minus 720, which leaves us with 4,320. So there are 4,320 ways that we can arrange the letters in the word leaving so that it does not start with a V. So in part 1, we found how many ways there were of having no restrictions. So the absolute total number of ways we can arrange this word is 5,400. In part 2, we found how many ways we could arrange it so that it must begin with a V, and we got 720. So taking 720 away from 5,040 will leave us with the ways that it must not begin with a V, and that leaves us with 4,320 ways. So part 4, how many ways do we have to arrange the word leaving if the arrangements must begin and end with a vowel? So the first letter must be a vowel. And there are only 3 vowels in the word leaving, A, E, and I. So there are 3 choices for the first letter. So for the first letter, we have a choice of 3. The last letter must also be a vowel. As we've already picked one vowel for the first letter, we now have 2 choices left. It doesn't matter what vowel we picked, but we would have picked one of them. So we've only got 2 choices left for the last letter. So for the 7th letter, the last letter, we have a choice of 2. Then the arrangements must be filled with the remaining 5 letters. So if we've used up one letter already, a vowel for the first, and we've used up a vowel for the last, doesn't matter which of the vowels it is, then 7 minus 2 leaves us with 5 letters. So we've got a remaining 5 letters. So the second letter, we have a choice of 5. The third letter, we have a choice of 4. The fourth letter, a choice of 3. The fifth letter, a choice of 2. And the sixth letter, a choice of 1. So it's going to be 3 by 5 by 4 by 3 by 2 by 1 by 2, which is 720 choices. Note that because the question asks for the arrangements to begin and end with a vowel, those are the choices that we filled in first. In general, we first fill in the choices that have restrictions placed on them.